All right, we're going to finish up chapter 2 with measurements in chemistry. One of the most common ones we use is volume. And in the definition of volume, it's how much mass and how much space you occupy. Well, that's a volume. For a liquid, it's really easy to measure volume because a liquid can be put into what they call a graduated cylinder, or we have all kinds of devices, and I'll go through those in a minute. But it's really easy to get the volume of a liquid. For a solid, we got to do a little bit more calculations, but you can look and see here's some devices. And again, this is the most common, graduated cylinder. We have different sizes. We have one that it's 10 times this size. We have ones that measure, this is 100 milliliter. That's the most common that we use. We have ones that only measure 50. We have ones that only measure 10. And actually, the smaller they are, the more accurate they are. This is a volumetric flask, and what happens is maybe you put a solid in here, and then if you fill it up to there's a little line on there, that tells you, it gives you the concentration. This is a burette, and a burette we use a lot in like titrations. They're very, very, very accurate because if I'm going to use a titration, I'm neutralizing something, and I have to make sure that the measurements are right on. This is a pipette. We have all kinds of this one. You'd have to put something on top, some sort of bulb, and you just stick it into your solution and pull it up, and it has marks. We have plastic ones. We squeeze the bulb and pull up so much. A syringe here. If you've ever had a shot, but I don't think they'd be in milliliters. They're usually much smaller than that because you don't get this much stuff when you get a shot. But again, these are ways of measuring volume, and volume is how much space something takes up. And if it's a liquid, it's really easy. It's just, pour it in a graduated cylinder and you can measure it. Okay. Common units are the liter, which, a 2-liter bottle of pop, that's 2 liters. So sometimes they have liters of pop, but 2 liters more common. Milliliters are usually what we use. That's the small unit. In a can of pop, a 12-ounce can of pop, you have 355 milliliters. I'll give you an idea. So we use milliliters a lot. If you're measuring a solid, you can't just dump that into a graduated cylinder. So if it's a regular shape, we measure the sides and we take length times width times height. That's why you see the milliliters cubed here, because you're just going to multiply those together. And we'll talk more about that in a little bit. Okay. Common relationships, again, 1 milliliter equals 1 centimeter cubed. It's really nice when you're working with water. They work really well. It's easy to convert from one because a gram and a milliliter equal each other. So it's nice with water. Okay, here's a problem. We're going to take liters to milliliters. Again, I know that 1 liter is 1,000 milliliters, so I'm going to use that. I'm going to take what I know, 3.45 liters, sorry. 1,000 milliliters in 1 liter. How do I know to set it up? Well, whatever's here goes here. So I want them to be opposite of each other. And then I'm just gonna multiply. There's 345 milliliters and 0.345 liters. Okay. Dimension analysis, what we've talked about already. Okay. And this one, now, if I was going to find the milliliters in a cube, okay, a cube is the width, the length, and the height are all the same. So what I would have to do is I'd have to change this to inches, from inches into centimeters, and a centimeter and a milliliter equal each other, centimeter cubed, sorry. And then I'd have to multiply my answer by 3 because length times width times height. Kind of a complicated one, huh? So again, I would convert inches into centimeters. 1 inch is 2.54 centimeters. We already talked about that. And then I would get 3.33 centimeters. So each side of my cube is 3.33 centimeters. And a cube, they're all the same. So I would take this times this times this, and length times width times height to get my volume. Multiply them all together. And I get 3.69 times 10 to the 4th centimeters cubed. Now I can change that into milliliters. A centimeter cubed and a milliliter equal each other, so that's still the same number. So again, dimensional analysis, multiplying by 1. Okay. Another thing we use in science is temperature. We use temperature a lot. Temperature is a measure of heat energy. What we're doing is we're measuring how quick those little particles, the atoms and the molecules, are moving around. When they're moving around fast, they give off more energy. That's why the temperature goes up. Okay. It's a measure of the intensity, how hot, how cold. Okay, so thermal energy is the energy that's involved with the motion of the particles. If you want to measure that energy, you use a thermometer, you use temperature. Okay, and we also have flow of heat. they go from high temperature to low. You know, temperature, or those particles like to even each other out. The SI, the System International, or the metric system unit, is actually called Kelvin. And Kelvin is based on absolute zero. In other words, there's no negative numbers in Kelvin. But the nice thing about Kelvin, it's based on the Celsius system. So that's what we use when our thermometers in chemistry measure Celsius, but we can convert it to Kelvin real simple. Okay, we use a thermometer. We actually use, if we ever get to go in the lab, we use what they call LabQuest, and they digitally read the temperature, which is kind of nice. Okay, so we have 3 common scales in temperature. We have Celsius, which is the scale we'll use in chemistry, Fahrenheit, which is the one we use in the English system, and Kelvin. And Kelvin is based on the Celsius system. Okay, the nice thing about the Celsius and the Kelvin is, look at the freezing point. Freezing point of water is 0 in Celsius, and it's 100, the boiling point. So it's a uniform scale. Fahrenheit 32 and 212, that's not very uniform. And if you look at the Kelvin scale, the difference between, if you want to convert Celsius to Kelvin, you just add 273 to it. So 273 and 373. So these two scales are based on each other. We only use the Kelvin scale when we talk about gases, and we'll do that later on. Okay, so again, you have kind of some crazy in the Fahrenheit. It's not very uniform. Oh, sorry about that. It's not very uniform, but the Celsius and the Kelvin are, and so that's why they're used in science. Okay, here's more of a demonstration of it, but again, the thermometer, the Celsius is much easier to work with than the Fahrenheit. Okay, if there's an actual mathematical relationship, the easiest one is to convert Celsius into Kelvin. And again, when we do gases, we'll do that. All you have to do is add 273. We're not even going to use the 0.15. We're just going to go with 273. So if you have 100 degrees Celsius and you want to convert it to Kelvin, you take 100 plus 273. It becomes 373. If you want to convert Fahrenheit, you got to take your Celsius temperature times 9, divide by 5, and add 32. And then if you're doing the other thing where you're doing Fahrenheit to Celsius, you have to multiply by 5, divide by 9, and subtract 32. So it's kind of a crazy system. And honestly, we're not going to use Fahrenheit. We're just going to use Kelvin, and we're just going to use Celsius. Okay? So if I want to, again, if I want to change, if I have 723 Celsius and I want to convert it to Kelvin, I just add 273. And again, we won't do Kelvin until we work with gases. Okay? And again, there's your crazy times 9, divide by 5, add 32. It's, yeah. We don't use the Fahrenheit scale, so I'm not going to expect you to do a lot of conversions with it. Okay? This one I can cheat at. This is our normal body temperature, right? 98.6. Well, I know normal body temperature in Celsius is 37. But I can convert it to, using that scale. You'll get all those numbers. But your normal body temperature is 37 in Celsius. Your normal, like room temperature when you're, in the 70s is like 27, to give you an idea. And again, I know we don't use Celsius a lot. We're a Fahrenheit, but everywhere else in the world they use Celsius. Okay, the last thing we're going to talk about is density. And density is when you're talking about those little particles. We said everything's made out of atoms or molecules. Well, how close are those particles? The closer they are, the more dense something is. Okay, so and it determines whether it's a solid, liquid, or gas, those things. It's easy to find density. It's mass divided by volume. And again, it just determines how close particles are. Okay, it's a physical property. The units depend on, most common would be grams per milliliter. If you have a solid, it'd be grams per centimeter cubed because you're going to have to measure. Okay, so it just depends on what you're looking at. And usually for gases, they do grams per liter because gases spread out so much more. And again, your units would just be whatever you start with, you can see. Okay. Here, the volume of a liquid changes as a function of temperature. In other words, usually as you heat something up, their density changes. Water, if you think about it, water is most dense at 4 degrees. But if you heat it from 4 up to like 100, now those particles are going to be really far apart because you're changing it from a liquid to a gas. So now it'll change. So density changes when you add temperature. So when we calculate density, we're doing it for the temperature that it's at. Okay. There's also something called specific gravity. It's the ratio of density to one substance to density of another. Probably the most common thing we use specific gravity for is if you ever test your antifreeze to see at what temperature it freezes. If you've got one of those little gadgets and they have a little bead in them, they use specific gravity. We don't use specific gravity a lot. It's a comparison. And again, if we have to work with that, I'll give you more information. Okay, so I'm going to do density. I have the mass, 323 grams, and I have the volume. So I said mass divided by volume. Okay, so 323 divided by 53. And the other thing I got to remember is when I get my answer, this has 3 significant figures and this has 3 significant figures. So I have to make sure my answer has 3. Why am I doing that? These are measurements. Okay, if it's an exact conversion, you don't have to do that. But if they're measurements, you need to do that. So I take this number divided by this number and I get 6.09. And notice my units, grams over milliliters. Okay, so this would be a very dense object. If you want to know if something floats or sinks, if its density is less than 1, it floats. If its density is greater than 1, then it sinks. And how do I know that? Well, water's density is 1. So that's how we based it on. Okay, the density of gold is 19.3. What's the volume of 25 grams? So now you can just manipulate the formula. Okay, mass divided by volume equals density. Well, if I know the density and I know the volume, if I multiply the density times the volume, density times the mass, excuse me, I'm just switching them around. So the mass is still in the same place, but now I'm going to switch volume and density. So I'm going to take 25 divided by 19.3, and that'll give me the volume. Okay. So 25, and again, I'm going to divide by that mass and 1.3 milliliters. That's not very much. Okay. If you want to find the mass of something and you have the density and the volume, you'd multiply those numbers. And again, it's just simple algebraic conversion. Okay. Let's see. What is the mass of 1.5 milliliters of ethyl alcohol? And it gives me the density. So again, I'm going to multiply those two numbers together because I have the volume, I have the density. So if I multiply those, they give me the mass. And again, I don't know if I have the formula here for you, but, oh, you can't see it, I'm sorry. But I take 1.5 and I'm going to multiply by the mass, and that's, or the density. And you can see grams, milliliters are going to cancel out, grams are left over. And if you can see the answer, you guys, it's 1.18 grams. Grams is a unit of mass. That makes sense. Okay. If this is like an experiment we would have done, sorry we didn't get to, but if you're trying to figure out the volume of a regular shaped object, if it's a regular shaped object, you can measure the length, the width, and the height and multiply. But what if it's not? What if it's kind of a funny shape? You can actually drop it into a graduated cylinder. Okay, here it says the graduated cylinder is filled with 35, and then I drop this copper nugget that doesn't really have a specific shape into it. I know what it weighs. That's easy. I put it on the scale. But once I drop it in there, its level goes from 35 to 46. Well, the difference between those two are going to be its volume. So I know now that its volume is going to be 11. Okay, so you can find, if you can fit something into a graduated cylinder, you can find its volume by taking what the initial volume was and the final volume and subtract the two. And that'll tell you the volume. And then if I want to find the density, I have the volume, I have the mass, I'm just going to mass divided by volume. So here's my scale. I drop my copper into it and it goes from 35 to 46. So now I know the volume of my copper is 11. Okay. So the volume is the final minus the initial, 46 minus 35. And so now I know the volume. So you can do that for a regular shaped object if it'll fit in the tube. If you want to find your volume, what you would have to do is you'd have to have a really, really big graduated cylinder. And you have it filled with water, and then you go in, and whatever it rises up to, the difference between the two, that's your volume. They do that if you ever get to do a fat tank. They have the, to test your body composition, but I don't know many places except for like universities that have that. Anyway, and then if I want to find the density, I take the mass, 98.1, divided by the volume, which I figured out. I multiply those two, and that's the density of copper, excuse me. And I know it sinks. It fell down. It's hard to find the volume of something that won't sink. You gotta kind of push it under. So it's easier to do this when you have a heavier object. Okay? I think we're done.